Okay, question 6. This was super tasty. There's a lot going on here. Okay, this is actually a level 7 plus question. I've seen questions like this on higher level papers as a starting point. So just reading it through, the first, fourth and eighth terms of an arithmetic sequence here. And then it goes on to say the first 3 terms of a geometric sequence. Before we go any further, luckily there's just one extra bit of information. It says that the first term of both sequences is 9. Okay, so thank goodness, that's a starting point. So let's just try and separate the two. Let's have the arithmetic here. The first term is 9, and the geometric here, the first term is 9. Okay, so the first term, the second term, the third term. Let's just generate the first, second and third. This will be 9 plus d. This will be 9 plus 2d. So we're not answering the question just yet, we're just trying to make sense of what the information is. And if you're given an arithmetic and a geometric sequence, it's nice just to get the first 3 terms, just to see what's going on. This will be 9 times by r, and this will be 9 times r again, which is 9r squared. Okay, so the first, second, third of arithmetic is there, and the first, second, third of the geometric is there. So now let's think about which particular terms we need. So this is going to be the first of the geometric, the second of the geometric, and the third of the geometric. Alright then. But it says the first, the fourth, and the eighth terms of an arithmetic. So we want the first, the fourth, and the eighth. Well, let's just adjust this then. The first, the fourth, and the eighth. And the formula book, u of n equals u1 plus n minus 1 d. So if we want the fourth, we'll be adding on 3d. Okay, so with this formula here, if you want the fourth, 4 minus 1 is 3. If you want the eighth, 8 minus 1 is 7. So we're going to go and adjust this here, because the fourth is going to be plus 3d, and the eighth is going to be plus 7d. And then I think we've got all the information we need, because it says the first, the fourth, and the eighth here form the first, the second, and the third here. So basically these things, these expressions, are actually equivalent to each other. So clearly 9 is equivalent to 9. But then we have 2 equations. 9 plus 3d equals to 9r, first equation. Then the second equation, 9 plus 7d equals to 9r squared, the second equation. Now this is going to be quite a tough simultaneous equations now. I think the way we might like to do this is either substitution or elimination. Okay, substitution might be easier, and what we're going to do is, where we see an r here, we are going to rearrange. So let's try and rearrange this. So rearranging 1, we get 9 plus 3d divided by 9 equals to r. And then can you see that where we see the r here, we're going to substitute for 9 plus 3d over 9 in there. So let's go ahead and finish off the question now. So in question 2, 9 plus 7d equals 9 times by r squared. Well, r squared is 9 plus 3d over 9, and we square it. Okay, so this is a pretty horrible equation to solve. Okay, and I mean, you can do a little bit of expanding with algebra, and I think this will turn into a quadratic equation. But I'm just going to go try and graph this and see what we can find. Okay, and I'm going to graph both sides and see where the intersection point is. So that could be the way of trying to get around the harder algebra. Dot insert a graph. So f1 of x is going to be 9 plus 7 times d. Instead of d, I'm going to have x. That kind of makes sense. And then the next one, Control G to open up the graph plotter. 9 times by open bracket. I'm going to get the fraction button from the menu here. And that's going to be 9 plus 3x on the top, divided by 9. And this guy here is powered up squared. There we go. And then on my graph, the intersection point is somewhere. Point. Menu, analyze graph, intersection. Let's go before. Let's go after. Okay, so it looks like I've got a solution here. Now remember, we're looking for d here, and it looks like it comes out that d equals to 1. We'll check to see if that makes sense. So it looks like d equals 1 because that's the x value. Let's write it down, d equals 1. Okay, let's just check that though in the original arithmetic. If d equals 1, then the arithmetic becomes 9. And then, oh, that could work. 9, 10, 11, 12, 13, 14, 15. So that might work. And once we know d, of course, we can then do this part b, which is finding the value of r, because we've got two equations here. If I use equation 1 here, if d equals to 1, then you can clearly see that 9 plus 3 equals to 9r, 12 equals to 9r, then r equals to 12 over 9. When you simplify that, that's actually equal to 4/3. You can have r equals 1.3 recurring, put a little dot over the 3 to show you it's recurring. So that's a tough one there. You could go back down to this expression here, and if you like your algebra, you can go ahead and expand it and tidy it up and see what happens.